Okay, so in this video we're going to go through some mixture problems, and the mixture problems are pretty straightforward. The key thing is just understanding how to fill up the chart, and then just remembering what to do with the chart. But it's not quite like the motion problems where you have to figure out the equation. The equation really flows naturally from the chart. Okay, so when we're dealing with mixture, essentially just to, generally what's going to happen is we're taking two substances that we're going to mix together, and then we're going to end with a substance. Okay, so we have our final substance is going to be our bottom row, and then we have our first and second substance that we're mixing together. Okay, and usually the order that we write those doesn't really matter. Okay, so our column headings, basically our first column is going to be the strength as a percent. Actually written as a decimal, but it's going to be given to us as a percent. The middle column is the amount of solution. Usually liters. It's not always liters, but liters of solution. And then the last column is the liters of the pure substance. A lot of times that's alcohol. It's not always alcohol, just depending on, it could be sodium, something or other, whatever type of liquid substance that we're dealing with. Okay, it's not always liquid. It could be, because we could do problems like this with coffee, mixing two different types of coffee, or mixing different types of nuts together, or something like that. Okay, so anyway, as we approach this problem, what we're going to do is we're trying to end with a 20% solution by mixing a 15 and a 30%. So I have a 15%, a 30%, and again, my final substance is going to be 20%. Okay, just kind of common sense here. This number right here has to be between the first two. Okay, there's no way I can mix two things together and get what I'm ending with without that being in the middle somehow. Okay, and just like the motion problems, it's really just the first two columns that I'm trying to fill out. Really, just the first two rows, first two columns. These four boxes is what I'm going to get from the problem. Okay. So we're looking for how many liters of the 15% solution should be added to the 3 liters of 30%. So we know we're going to have 3 liters of 3%. We don't know how much of the 15%, so that's our x. Okay. Now, the final substance, the amount of liters that I'll have for that final substance is going to come from adding these two things together. So that's just going to be x plus 3. And just like we did with motion problems, we're multiplying the first two columns together to get the last column. So I'm going to have 0.15x here, 3 times 0.3 here, and then 0.2 times x plus 3. And so, again, these percents relate to alcohol for this particular problem. So this represents how much actual alcohol is in the first one. This represents how much actual alcohol, which we can find, is in the second one. And then this expression represents how much alcohol is going to be in the final 20% substance. Okay? All right, so the equation is very straightforward. It's always the first two boxes added together equals the third box every single time. I shouldn't say every single time. Sometimes you have to subtract. We'll talk about that here in a bit. So, but generally it's going to be just adding these two boxes together to get the third one. Okay? Okay, so now it's just a matter of working these out. So you have to be real careful with the decimals. That sometimes throws people off a little bit. So when I subtract 0.15x, that gives me 0.05x. And I would also subtract 0.6 from both sides, which gives me 0.3. And then 0.3 divided by 0.05 is 60. Okay, so the question was how many liters of the 15% solution? That's x, that's what we just found. So the answer is 60 liters. Okay, go ahead and try this next one on your own, and then I'll go through it. Okay, so as I set up my chart, I'm mixing together a 25% to a 10%, and my final solution is going to be, or the final percentage of my solution is going to be 0.15%. Okay. I have 5 liters of the 10%. I don't know how many liters I'll have of the 25%. And what I'll end up with then is x plus 5. Okay, so again, I multiply the columns across. I have 0.25x times 0.1 times 5, and then 0.15 times x plus 5. And so again, the equation, the top 2 boxes added together equals the third box. So 0.25x plus 0.1 times 5 equals 0.15 times x plus 5. All right, so work through it here. Subtract 0.15x from both sides gives me 0.1x. Subtract 0.5 from both sides gives me 0.25. And then remember, always divide by the number in front of x, which is 0.1. And so x comes out to be 2.5. Okay, so the number of liters we need for the 25% antifreeze is 2.5 liters. All right, one more, and we'll do with just an investment type of problem. Okay, and it's the same idea here, just the equation is going to be a little bit different. Okay, so in this case, I know I don't have a lot of room here, but I'm going to try to fill out this chart over here in the corner so you'll be able to see it. Okay. In this case, there's only going to be 2 rows. And so we have the first investment and the second investment. Okay. In this case, we're dealing with interest, and so we're doing simple interest. Okay. So the principal times the rate times time is equal to simple interest. So in this case, we're going to have 4 columns. Principal, rate, time, and interest. And so we need to fill in the first 3 columns, and the last column, interest, is where it's going to be just multiplying those first 3 together. Okay, so first of all, the principal, and this is very similar. What I'm going to do right here is very similar to most of these types of problems. There's a total of $410,000 that are going to be invested. We don't know how much in either one. So what we're going to say is that one of them is X, and the other one is 410,000 minus X. Didn't leave myself much room here. Okay, and it's not X minus 410,000, it's 410,000 minus X. All right, so the rate, I have the 4.65%, so as a decimal, that's going to be 0.0465. And then the other one is going to be 0.0491. And it doesn't really matter which one goes where. That can be switched. Okay. The time, well, for 6 months, that's a 4.6%. So time should be in years. So for that, the time is going to be 1/2 or 0.5. And then the time for the other one is going to be 1. Okay. So our interest from that first investment is going to be 0.5 times 0.0465 times X. I didn't leave myself a whole lot of room here. And then the last one is going to be 0.0491 times 410,000 minus X times 1, but I don't need to do the 0.1. Okay, so the equation then is the total interest is going to be the 14,961. So we're just adding these 2 together, setting it equal to that. Okay, so I have 0.5 times 0.0465 times X plus 0.0491 410,000 minus X equals 1,961. Okay, so a lot of decimals here. We just have to be careful get our trusted calculator to work these out. So 0.5 times 0.0465. And I'm distributing here on the second parentheses. Okay, that should be an x right there. So I'm going to combine my x terms. And I'm going to subtract 20,131 from both sides. I then divide by the number in front of x. Okay. Which, believe it or not, comes out to be exactly 200,000. Okay. So how much should be invested at each rate? Well, the x is a 200,000. That's at the 4.65%. Okay. So make sure you write your answer specifically about how much at each rate. So it's going to be $200,000 at 4.65%. And then the second one, 410,000 minus 200,000 is 210,000. So 210,000 at 4.91%. And that's it.